guys, what's up? I'm here with another topic of biomolecule, and like most of you know, these days we were doing fructose. So this is going to be another very important section from fructose, and I'll be talking about Howarth structure. Right now, before I even help you doing that Howarth structure, we have to repeat back how the cyclic structure of fructose from the open structure was developed, right? So once that open structure is again clear for you, you can definitely and easily draw the Howarth structure. Another thing I will discuss in this lecture is that why we needed a structure like Howarth, because because that open structure when converted into cyclic, that was also enough to get the cyclic form of the fructose, right? So let's see that and get it through. So the first thing I'm doing here, I'm taking the open or a straight cyclic structure. So the second carbon of the fructose had OH on the right hand side. In case you have missed this lecture, I would suggest to check out the very previous lecture where I've described everything related to how the structure is developed. So this second carbon has a OH on the right hand side and CH2OH on the left hand side. So this is the structure, the second, third, fourth and the last one. So this is your first carbon, second, third, fourth, fifth and sixth. This sixth one is again in the form of CH2OH. Now if you remember, this fifth carbon was in the form of ring. So what I'm going to do, I'm going to make a ring here right over there by placing an oxygen here. So this fifth carbon, just pay attention, this fifth carbon and this second carbon is having a ring development using the ketone group from here and OH group from there, and other things are as usual. This one is here as H, left hand side you have OH here, and then you have OH here, and there you have the H. Similarly, this one is also having a H here. So this is the pentacyclic structure. This is the pentacyclic structure of fructose, right? I should write the proper name. So it's your it's your alpha. Why alpha? Just give me a second. So this is your alpha. D refers to the glyceraldehyde relationship, and then you have a minus sign which represents to levorotatory and the fructose. So this is the complete name of the the structure I just made. But let me repeat why this is alpha. When you have this second carbon OH on the right hand side, it is alpha, but if it was on the left hand side, it was called the beta, right? I have already done that. In case you are missing and in case you have forgotten, what you need to do, check out the very previous lecture of yesterday. You might find it somewhere on the channel. So just go back and check out that, because without that you might be having problem here. So now we have done the pentacyclic structure of fructose. Now let's draw the Howarth structure, which is our main topic. For Howarth structure, what we need to draw a structure like this one. So pay attention. This is going to be interesting here. So this is a pentacyclic ring. This first one is in the form of oxygen, right? Now you have to draw vertical lines here. Sorry about this one. So you have to draw a vertical line over here, again a vertical line over here, third one right here, and the fourth one right here. Okay, so what I'm trying to draw here, let me write it first. This will be alpha, this will be alpha, D, right? Again minus and fructose, right? So this is the alpha form of fructose in which when you draw it called Howarth structure, because this is not the Howarth structure, this is just a cyclic structure. But this cyclic structure, when represented in this form, it is called Howarth structure. Now what you have to do here, everything that you see here is on the right hand side, the OH, H, OH, OH, right? You need to place them down here. So what I'm going to do, I'm placing the OH here, right? OH here, then again H here, then this OH again here, and then this last one is again out, so this will be the situation CH2OH. right? In case you do not see it proper, let me give it a bit space. So CH2OH, this is the 6th carbon. What that means? You have to place all of these on the other end. So this is also going to be a CH2OH, right? There you have a H here, OH here. You have a OH here. Then you have H, and similarly this one is having H here, right? So this is the thing. Pay attention what I just did. I placed OH, H, OH and these CH2OH on the lower end, So OH is right here, H is right here, OH is right here, and this CH2OH is again over there. So in the alpha D glucose, both of the CH2OH, where this is the first carbon and this is your 6th carbon, they are on the upper side. Now pay attention, when I'm trying to take you through the beta one. So let me write the name first. This is going to be your beta. So this is your beta, D, again levorotatory and fructose Okay, so what you need to do, you draw the same thing, a structure similar to this one. This is your oxygen, and there you have your ring. So what you need to do, draw again 5 vertical lines over here, 5 vertical lines over here, or 4, sorry, 1, 2, 3, 4, and then just change the configuration around this 2nd carbon. Please concentrate here. I'm changing the configuration around the 2nd carbon. What I will do, I will place the CH2 on the right, on the down way, and OH on the up way. So I'm placing this OH on up way and CH2 here on the down way, and everything else will be similar. So this is going to be OH here, this is going to be H here. Similarly, you have OH here, then you have another H down here, in here, and then you have your CH2OH, you have your CH2OH here, and this one is having a H. So what difference do you find is that, this 2nd carbon configuration is different. The 2nd carbon configuration is different. In the alpha one, the OH is on the down way, but in the beta one, the OH is on the up way. So what we see, that there is one carbon whose configuration is different, than rest of the carbon. So this is, in that case, you can call this, you can call this anomeric carbon. So I'm just writing here, this is anomer. This is anomeric carbon. Anomeric carbon. So this is your anomeric carbon. Similarly, this is also your anomeric carbon. Pay attention. This is also your anomeric carbon, right? So this is how you can draw the, Howarth structure. In the alpha, the 2nd carbon OH is down here. In the beta, the 2nd carbon OH is up there. That's the only difference, and everything else is similar, right? So that's why its 2nd carbon is anomeric. Remember, when you compare glucose with the fructose, the glucose one had 1st carbon as anomer, but the fructose is having 2nd carbon as anomer, right? Now, we are approaching to, ending this, lecture. Let's talk about why we needed this Howarth structure when we had this structure available. I tell you what, there is a molecule, right? And what that molecule is, pay attention. There is a molecule I'm trying to draw here, and just give me a second. So this is your structure. Okay, and this particular structure has a double bond right here, and this is called furan. Pay attention, this is called furan, right? Now, Howarth believed that these two cyclic structure of fructose had some similarity with the furan. The two cyclic structure of fructose has similarity, structural correlation, structural analogy with the furan, and therefore these two structures were designed, something like this. And that is also reason, they have a different name as well. So this is also called, just pay attention, this one is also called alpha D, and again levorotatory fructofuranose, furanose, and this one is called, beta D, again minus fructofuranose, FURANOSE. Fructofuranose. Right? So, because of the structural analogy with this particular molecule, the two cyclic structure of the fructose were also called fructofuranose. That fura is coming from the furan and the fructose structure has some similarity. Right? So, Howarth came with this particular idea and named this two structure as FURANOSE structure. You can also call it in short FURANOSE structure. The proper name is alpha D minus fructofuranose, beta D minus fructofuranose, right? So these are something, I wanted to make you go with all those related to, this Howarth structure. I hope I have made you really well. In case you have problem, what you can do, you can, repeat it, right? Because it's a lecture in the form of a video. So what you can do, you can repeat it and don't give up, right? Don't give up. You may change your option, but things will be absolutely the same, right? Things will be absolutely the same. So don't change yourself and make it, don't make it go yourself to some cheap option, right? So that's what I'm saying. Anyway, thanks for watching. Take care and do let me know how good or bad this was.